This video will cover the third page of notes on the topic of rational functions. Let's start with example number 3, where our job is to graph f of x, where f of x is equal to a negative 1 over x minus 1 squared. So our first question should be, when is f of x undefined? So that we can find our vertical asymptotes. So we're going to ask ourselves, when is this denominator equal to 0? We can take the square root of both sides and we will get x minus 1 is still equal to 0 because the square root of 0 is 0. Then we solve and we'll find x is equal to 1. So that's how we found x is equal to 1 as our vertical asymptote. From here we can go into graphing and remember that we know what our parent function looks like, but because we have our negative in front of our function, we're going to make sure that it goes downward like this. So when we're graphing, we know that this part says move to the right 1. So you can see my vertical asymptote right here in green at x is equal to 1. Then we need to go to our horizontal, but since we didn't move it up or down, it's still going to stay here at y is equal to 0. So again, we can see this part here, it did not move it up and down. So our end behaviors for our graph will still remain the same. In other words, as x goes to negative infinity, the y values are getting closer and closer to 0, in this case from below. And we do the same thing over here. As x goes to positive infinity, the y values are closer and closer to 0 from below. Because my end behaviors are going to the same thing, 0, they're both going to 0, then we know that our horizontal asymptote will be y is equal to 0. But another condition we can see is that it did not have a vertical translation up or down. So again, we've already taken a look at our end behaviors, and I've noted them there. Let's go to example number 4. For example number 4, our job is to graph f of x is equal to 1 over the quantity of x plus 2 squared minus 3. So the very first thing we're going to do is ask ourselves, when is f of x undefined? In other words, when is the denominator equal to 0? So we're going to solve that. I'm going to take the square root from both sides. I get x plus 2 is equal to square root of 0, which is 0. And then I'm solving, and I will find that x is equal to negative 2 is our vertical asymptote. The next thing we need to do is to graph, or we can sit there and notice that this part right here that says minus 3 is going to give us our horizontal asymptote. If we graph, it makes more sense. So let's do that. So first I'm going to start with my vertical asymptote that says x is equal to negative 2. So I'm going to go over here to negative 2 and do a vertical in green. Then I'm going to go in blue. We went down to negative 3, so it'll be negative 3 down here. And now I'm ready to graph. From here, we're going to go to our new origin, and then we're going to remember our parent function, which is 1 over x squared, which means it goes like this. Didn't have a multiplier. From here, we're going to go straight towards our asymptotes, straight towards our asymptotes. We're going to go to our new origin, go to the left one and down and up one, because its parent function looks like this. Go towards my asymptote and towards my asymptote. So now that we have the graph, we can take a look at our end behaviors. As x goes to negative infinity, notice my y values are getting closer and closer to negative 3. And we do the same thing on the right side and one thing. So here's our solutions for our end behaviors here. From our graph, we can also determine our domain and our range, as well as our increasing and decreasing intervals. So I just want to remind you of that. I'm going to use my highlighter. We're going to start from the left graph. We can see that it's going higher and higher and higher. So we have an increasing interval from negative infinity until we get to negative 2. We jump over and then we're going down, 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 down. From negative 2 to positive infinity are the x values. So I'm just trying to remind you that these are the x values and the y values are described in the words increasing and decreasing. And that concludes this video.